All right, I'm back. Okay, so just as a reminder of a whole bunch of due dates and such coming up, because there's a lot right now. 4.2 and 4.3 are due today. That's the 6th. 4.4, these are my math lab homeworks, is due on the 8th. We'll finish 5.1 today, as well as getting into 5.2. And because of the midterm coming up, because of the project coming up, I'm going to give you a little bit of slack on this homework due date. Don't expect that anymore, though. It'll be a week after the fact. Moving forward, so that's going to be due on the 15th. Remember, our project is due the 8th. That's 2 days away. That's your budget project. You should have been working on this all throughout March. We had plenty of time to organize our expenses, what little expenses we might have. I don't know about y'all, but I have certainly cut most of my expenses out due to what's going on, because who knows what's going to happen to our finances. Some of us are without jobs. I usually teach summers, maybe summer school will be a little rougher. Who knows? So I am budgeting accordingly, and maybe some of you seeing your expenses would do the same. And I'm not telling you what to do. I'm just saying maybe you would have a reaction to it. Excel 5.1, that's our next Excel assignment. That's going to be due on the 15th. Please don't wait until you've turned in the midterm to start this and complete it. Put your eyes on it. Look at the instructions. See what you're going to have to do, because you don't want to just have to get all this together in 2 days. It's not a tough one, but it's another case of you have to follow the instructions that you are given. So many of you are losing point after point after point because you're not paying attention and following instructions. And I don't even know how many times I've said this in this class, how important that is. There's a lot of little details where you might think that something is done appropriately and it looks good, but because you don't follow exactly what the instructions in the Excel assignment say to do, it's going to be wrong. And the project was a little more open-ended. I didn't give you a pre-formatted thing. You had to come up with that on your own, but I did tell you how to set it up and what to do, what your rows should be, what your column should be. Please make sure you understand what it means to be a row and a column. I've had at least 2 different people emailing me setups that have those backwards. So make sure you understand that columns run vertically, rows run horizontally. Your midterm, I said I was going to email it to you, and our test determined that that was a lie. Sorry, terrible reference. I put it in Canvas. I don't know why I said I was going to email it to you previously. That was never in my intention. I just had, I got scatterbrained for a second doing this. So your midterm review is available in Canvas. That's where it was placed. It is closer to 60 questions. I want to say it's 58 or 59 questions. I believe there's also one in there that you're supposed to skip, and it says it in the title of the review if that's the case. I'm pretty sure it had it there. I'm sorry, I just finished my pre-calc 2 class, so I didn't have time to remind myself of that. The midterm will be available in your assignments section starting on the 8th. That should be live at 12:01 a.m. on the 8th, so in 2 days. And then that's going to be due on the 13th by midnight. It's 20 questions, so it's significantly shorter than the review. Basically, I took 18, 19 of the questions from the review. I changed the numbers, and I called that a midterm, and then like one question might be just a little bit different. And I'm not saying significantly different, I mean just a teeny bit different. It's still basically in the midterm review. I just played around with the question a little more. So this midterm review, if I see, well, I won't see because it's not never mind, it's not on my math lab assignment. Trust me, you need to do this midterm review. And again, I'm giving you the questions and the answers. You're responsible for the work in between, using your notes, using the stuff from my math lab, using the textbook, using the workbook. I've given you lots of good notes, lots of good examples that most of this stuff goes based on. There might be 1 or 2 or 3 that are a little more challenging, but we've still covered every single type of those problems in class. So 20 questions, you get 2 attempts on this midterm. I will only take your best attempt. I am not guaranteeing any kind of partial credit. It's going to be extremely rare due to the fact that I don't know that the work you have on your piece of paper has been edited after the fact. If, oh, well, here's my work with, every single answer is correct, you get 100. No, I don't know about that if I'm looking at a 42 or something like that. So it's really, really going to be rare. And even for syntax issues, I'm not going to just give you a syntax issue necessarily. You've got to, again, the whole theme of this class is pay attention. So if you're missing a decimal point, that's not going to be acceptable. I'm not going to give you partial credit for something like that. If you accidentally type an X in the number or something like that, you know, it's going to depend on the situation. I can probably be lenient for that, but please just pay attention. Please make sure it's right the first time, because it is not easy to go back and edit this. All right, so why won't it let me? There we go. I have to hit the Windows key. Let's pull up our notes. Oh, I know why, because I'm on Annotate. Back what we had last time, just as a super quick reminder, and then we're going to dive right back into the worksheet. This is only going to stay up for a minute. This was on our notes last time. This is in the Canvas shell to download. So we talked about plotting points. The first value tells you how far left or right you go. Second value, up or down. We said to look for patterns. We showed you what we meant with that. We talked about how you only need 2 points to form a line, but you can still draw a line with 3 or 4 or 5 points as long as they're all straight and connected. If they are not connected as a line, then that makes them a curve. So if you had points like this, if you connected them, sorry for my crappy drawing, that's a line. But if your points look like this, you can't connect them with just a bunch of line segments. This is not how things work. These are a bunch of little straight line segments. That's not how we do things. That's instead what we call a curve. It bends to those points. See, I'm bending. I'm trying to not draw little straight line segments. And in fact, if you've been paying attention to the news, you should have seen this shape once or twice, how it relates to the coronavirus. Now, this in particular is an exponential curve, which the coronavirus is modeling for now, but eventually it goes logarithmic, or excuse me, logistical. And we don't have to worry about that. We won't do any of that math, but it is fascinating either way. So that's the difference of a line and a curve. Now, when we're talking about using data to approximate something, you may not hit all those points. So you might have points that are like this. So if this is for a bunch of data, you want what's called a line of best fit. I'm drawing this as straight as I possibly can. You may not go through every single point. And this is something that we will get into in this chapter and continue to see as we move forward. So when you have points that fall exactly on a line, they'll all connect. When you're given data and using to make a model, approximate a model, anything like that, they may not fit exactly. And the good thing is we generally don't have to come up with this line because the math behind it is a nightmare. It takes us a very, very, very long time just to develop the pain in the butt formulas, and then the application of them is long. The good thing is Excel will do this for us. So we're going to be relying on Excel to do what's called a line of best fit. Or if we're doing an assignment, then that would already be assigned to us, as we'll see. Then as a reminder, linear equations are just the sum of a variable amount and a fixed amount. The variable amount is something like an AX. The fixed amount is a B. Variable amount means it has a variable with a number. Fixed amount means it's just a number. All right, let's clear the screen, take off annotate, and let's go back to this. There we go. So last time we talked about this, the 5 and 7 minute plan, and how you can see their slopes develop. The larger the variable cost, the steeper the slope. We'll start talking about slope more in the next section. But we did talk about the idea of run and rise to go from point to point. And then we showed this example, how, let's see, red. These pairs make the red line here. And then these separated ones these values, with these values, I went a little low there. It's the 45 is included too. Make this one, although it only stops at the 300. So it's really just the first three seen. The red one is the same as before, but the blue one is adding a fixed cost of $20. So that was our monthly fees being added to our cost per text message. So if you spent $5 just to text, that made your bill actually cost $25. If you spent $10 in text messages over 200 minutes, that makes your real bill when you add the 20 bucks, $30. So this blue curve is really, sorry, blue line, not curve, because it doesn't bend. That is the real cost. And these black lines are something that we normally do not draw. It's just an illustration here saying that the fixed cost of $20, that's the effect it has on it. It brings the red line up 20 units. This 0 is up to 20. This 5 is up to 25. This 10 is up to 30. This 15 is up to a height of 35. So the blue is really the data we're after. So let's actually try filling out one of these. This is where it would be group work. Scroll, I'm gonna annotate, that's why, sorry. So, the weight of water. The weight of water is proportional to the volume at a rate of 8 pounds per gallon. Proportional means that's the multiplier. In other words, this is the variable rate. I got something covering my screen that y'all probably can't see. So this 8, that's the variable amount. The reason? Because it has a per. So if you have 1 gallon, then the weight would be 8 pounds. If you have 2 gallons, the weight would be 16 pounds, 2 times 8. If you have 3 gallons, 3 times 8 would be 24. That's the idea of proportional that we've used before. You can set it up as a fraction equal to a fraction, but it's a lot easier to use the extended concept where this is just the multiplier. That's the number that goes in front of your x. Next, assume the bucket you're using to carry the water weighs 10 pounds. So this first column that we're going to fill out is just the weight of the water. So if we have 0 gallons of water, that means that we're going to have 0 pounds of water, because 0 times 8 is 0. I'm going to skip to the 1 because I think it's a little easier. If you have 1 gallon, well, it's 8 pounds per gallon, so that's definitely going to be 8 pounds. 1 gallon of water would weigh 8 pounds because of the variable rate, 8 pounds per gallon. Now let's go back to the half a gallon. Half a gallon, well, that's half of a whole. So the half a gallon is probably half of the 8. And you don't have to do it that way. You could just say, oh, that's your multiplier. 8 times a half is 4. And sure enough, half of 8 is 4. So 0 gallons is 0 pounds of water. A half a gallon of water is 4 pounds of water. 1 gallon of water is 8 pounds of water. And all we're really doing to get these numbers is taking 8 times, I'm going to write it as a V instead of X, V for the number of gallons. All right, so the 1.5, well, you can see every time we go up a half a gallon, we're going up 4 pounds, half a gallon, up 4 pounds. So we went up a half a gallon, so we're going to go up another 4 pounds. So that's going to be 12. I'm using patterns here, so that's a 12. Then if I go up another half a gallon, it's going to go up another 4 pounds, so that would be 16. So again, each of these is going up 0.5, and this goes up 4. So then going up another half in gallons means we're going up another 4 in pounds, so that would be 20 pounds. So again, the blue stuff is just the weight of the water. In red, we're going to account for something else. We're putting this water in a bucket, and buckets have weight. And we got a really heavy bucket. This bucket is 10 pounds. So no matter how much water you have in that, you're going to be carrying an additional 10 pounds. This is the fixed amount. It doesn't change. Your bucket, the literal bucket, does not become heavier by putting water in it. The total weight of the bucket and the water is what's changing. The bucket stays the same. It's the water that's changing, which does make the total weight, which is your water weight plus 10 pounds. So all we're going to do is take all these blue numbers and add 10. 0 plus 10 is 10. So if you have no water, the total weight's 10 pounds because it's just the bucket. If you have 4 pounds of water, then the whole thing weighs 14 pounds because you got your 10-pound bucket plus your 4 pounds in water. If you have 8 pounds in water, the total weight's 18. 10 plus 8. 10 plus 12 would be 22. 10 plus 16 would be 26. 10 plus 20 would be 30. Then what they ask us to do is to plot the points and sketch the graph of both of these functions. Be sure to label the axes. So the axes are not labeled for us, so we've got to label them. Now this bottom thing is going 0, a half, 1, 1.52, 2.53. Pay attention to those numbers because the things we're talking about are gallons or pounds. Or you could say volume and weight. Either thing would be accurate. I'm going to use the words volume and weight since they're a little more general. The 0, the 0.5, the 1, the 1.5, the 2, the 2.5, and the 3, well, that's these volume amounts. Now, even if I didn't see those numbers at all, the horizontal axis in the world of math is always the input. The left side is always your input. The output are the right sides. So the horizontal axis is your volume. The vertical axis is going to be your weight. I am going to have a terrible time trying to write this vertically, but I will try my best. This is extremely weird. Hey, there we go. So I'm going to do the graph of just the water, no actual bucket in blue. And those heights were 0, 4, 8, 12, 16, and 20 for these amounts of going right. So 0, 0 is the first point. They even basically give that to us if you saw that. 0.5, 4, so we go right a half and up 4, which is here. And they gridded these so perfectly for us. That is not always done. Then 1, 8, so we go right 1, up 8. 1.5, 12, we'll go right 1.5, up 12. 2, 16, that means you're going to go right 2 and up 16. 2.5, 20, that says we go right 2.5 and up 20. So they were very nice again and made all those points on the corners. How thoughtful of them. And then we connect these with a line. These definitely look like a line. I'm going to do my best to make this a line. Please, please, artistic ability with this pad. I can't tell you how weird it is to write and then be looking at the screen while you're writing. It's just awkward. And then really this pattern is continuing forever and ever and ever. So what I like to do is continue it and put an arrow on the end. Now I'm going to switch to red. Now remember, this is just the weight of the water. In a real world context, you can't just be holding the water, you got to have the bucket. And the bucket you happen to have weighs 10 pounds, so the red line is going to be the actual weight you'd be carrying from place to place. So the first height was 10 for 0 gallons. So we go right 0, up 10, and you can see they put a little circle there just to give us a hint to start off. And that's halfway between the 8 and the 10, the 8 and the 12, excuse me. So that's not going to be on these little corners. The next one is going to be 0.5 and 14. Remember, we're using, for the red, we're using these numbers. That's our input and output, our X and our Y. So 0.5, 14. So we go right a half and up 14. Now 14 is not on the labels, but it's halfway between 12 and 16, so it should be there. Then we'll go 1, 18. So we go right 1, so 1 gallon. And that had a weight of 18 pounds, which would be here. Then when we had 1.5 gallons, the weight was 22. So right 1.5, up 22. When the volume was 2 gallons, the weight was 26. So right 2, up 26. Oh, I actually kind of hope y'all can hear my dog snoring right now. He's next to me. You might, I don't know how good my mic is, but it's funny. Sorry, I'm distracted. Okay, the joys of being at home. Next, we had the 2.5 for the volume and the 30 for the weight. So we go right 2.5 and up 30. There are our points that we will connect with a line as best as your teacher can. Again, these are not little line segments. I'm just having a lift to do the best thing I can. That should be a perfect line going through those if your teacher was an artist and used to this drawing tablet. So again, the red one is the actual weight with the bucket. So this is the weight with the bucket. So the bucket takes every single one of the weights of the water and moves it up 10 pounds. And again, I'm not actually going to show those vertical black arrows because that's not something you would normally ever draw. And there we go. That is how we graph lines. Did I need all those points technically? No, I only need 2 points to graph a line as long as we know that this is proportional based on the variable amount and there's no other kookiness to it. In the real world with real data, especially when we're talking about people over time, anything having to do with us, any kind of model, generally things fall apart eventually, as we'll start seeing. So I'm gonna give you another 15 seconds to get that down in case you're still writing, but I'm gonna have to clear my screen and move things. Remember, if you ever don't finish something, these always get uploaded to YouTube within an hour, and you can go back and pause. Was that a question? It was not. Sometimes this thing makes the noise that someone asked a question, but that no one actually asked a question. And it's kind of weird. Gotta love technology. All right, so let's clear our screen. Let's do another one of these. Go off of annotate, please, and thank you. Can I move this? I can't. Let me scroll out just a little. Sorry if this one looks a little small, but in order for me to have this on the screen at once, because it's on different pages, I have to have it this way. So, buying tickets. The cost is proportional to the number of tickets you buy at the fair at a rate of $2 per ticket. Next, assume there's a fixed cost of $15 to get into the fair. So when you go up to the gate, they say $15, please. And once you're in, then they're going to charge you to ride the rides on top of that. You know, not that big a fan of this type of fair. It is what it is, though. I'm more a fan of the Busch Garden style where you just pay your flat fee and then you ride the rides however many times you want. However, you could argue that going into Busch Gardens still follows this type of model, except your tickets, the variable rate is based on your cost per ticket. And the fixed cost, well, a lot of y'all might have to pay to park. So there would be a fixed cost that would be the parking. So no matter how many people you have in your car, you're still going to have that fixed cost. So you'd be talking about the total cost of your whole family. So let's say the cost of a Busch Gardens ticket is $100. I know it's a little high, but let's just say it's $100 for the sake of easy. So each ticket costs $100, but then they'll charge $20 to park. So if you got 4 people in the car, you're going to pay $400 for the tickets plus the $20 to park, meaning $420 for your day of fun. If you have 2 people in the car, you're going to pay $200 for the tickets and $20 to park, so $220. All right, so this is the fare, $2 per ticket for a ride, and then a fixed cost of $15 to get in. Same thing, let's ignore the fixed cost. Let's just talk about the variable cost at first. All right, annotate. So $2 per ticket, that is our, let me switch back to blue to be consistent. Undo blue. So the $2, that's our variable cost. How do we know it's variable? Because it's based on per. That's a per unit. So 1 ticket, $2, 2 tickets, $4, etc. If you buy 0 tickets, well, that's $0. If you buy 5 tickets, well, if they're $2 each, 2, 4, 6, 8, 10. That would be $10 for the 5 tickets, or 5 times 2, because it's just the variable cost times the number of tickets. If you buy 10 tickets, 10 times 2 would be 20. You don't even have to keep doing that math. You can identify your pattern. Every time the tickets are going up 5, the cost is going up 10. So if we go up another 5 in tickets, the next cost is going to go to 30. If we go up another 5 in tickets, the next cost goes up 10 to 40. If we go up another 5, the next cost goes up to 50. Now, if the next one was 27 tickets, it would not be 60 because that would change the pattern. So if I asked for 27, you would definitely have to do 27 times 2, which would be 54. I say that because maybe that happens in a later worksheet. All right, so now let's switch to red. Not magenta, red. So now we're going to add in the fixed cost. So let's say you go into the fair and you hate rides. They scare you, you hate them, or you just are managing so many people you don't have time to actually get on the ride. You're just watching and waving, whatever it is. So you buy 0 tickets for yourself, but you still got to pay the $15 to get in. So if you buy 0 tickets, that means you're still paying 15 bucks to get into the fair and watch your little kiddos. If you buy 5 tickets, which meant you paid $10 in tickets, that means you're paying a total of 25 to get in. If you buy 10 tickets, which cost 20 bucks for those, you still got to pay your 15 flat fee. That means you're going to pay 35. We're just adding 10 to each of these numbers. So the next one's going to be 45, the next one's 55, and then finally we get 65. And if you don't trust that last one, 50 plus 15 is 65. So again, that right column is your actual total cost. All right, switch back to blue. So when we bought 0 tickets, before we account for the $15 at the gate, just the cost of tickets is going to be the blue. That'll cost us 0 bucks. When we buy 5 tickets, that's going to cost us 10 bucks. When we bought 10 tickets, that costs us 20. When we buy 15 tickets, that costs us 30. When we buy 20 tickets, that costs us 40. Let me get rid of that extra little dot. When we bought 25 tickets, that cost us 50. And if we bought 30 tickets, that would cost us 60, but we didn't go that far in the table, so we stop. Connect these with a line. Straight, 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 straight. Straight, straight, straight. We're not bending. And again, this is all we actually modeled, but we can see there's a good pattern, so I like to extend this and say that that goes on for at least a little while, maybe infinitely. So that was without the 15 bucks at the gate. Well, that cost is irrelevant. It's nice to see, but in reality, we didn't pay $0 if we bought 0 tickets, we paid 15. So the red will be the cost with the cost of entry and tickets. Then the next one has a height of 25, then 35, 45, 55, and 65. So when we bought 5 tickets, our total cost was 25. When we bought 10 tickets, our total cost was 35. I'm trying to make these as centered as I can. When we bought 15 tickets, that was 45. 20 tickets cost us 55, and 25 tickets cost us 65. If we bought 30 tickets, that would go up another $10 to $75. But we didn't even go that high on the graph. Connect with a line, straight, 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 straight. If you need a ruler, use a ruler. If you don't, I am not going to penalize anyone on a handwritten test for something like this. And this isn't what we'll be doing for handwritten tests. You wouldn't have this many points. It would just be plot 2 points and connect them. And also, it's not going to be a handwritten test, so it's irrelevant. You'll be picking from multiple choice answers. All right. So again, the red one was the total cost. That is the real answer. The only reason we did the blue one was, again, just to show what that fixed cost at the gate does. Moving forward, after this next worksheet problem, we're not going to do that blue stuff anymore. I would only want the red. All right, so I need to clear my screen so I can scroll. And I can zoom back in. Oh, I forgot to label the axes, didn't I? Please make sure you go back and fix that. The axes, the 0, the 5, the 10, the 15, that was the number of tickets that we were buying. That was the thing on the left column. Then the right column, those were costs. I don't have time to write it vertically. Please go back and make sure that you have those labeled. Okay, now we'll get to the next one. Driving distance. The distance you drive is proportional, so that means a constant multiplier, to the time driving at a constant speed of 40 miles per hour. So 40 miles per hour is going to be our variable rate. How do I know it's variable? The word per. Per hour means more hours, means more distance covered. More time, more distance. Next, assume that the distance driven includes 100 miles you already drove. So you filled up your tank, then you hit the road for a road trip, and 100 miles down the road, you realize, oops, I forgot to reset my my trip. So that's when you hit the trip button, because it says something like 586 miles, which is irrelevant. And you know you've gone exactly 100 miles because you saw a road sign or something significant. Maybe you've done this trip 5,000 times, whatever. You know you've gone exactly 100 miles. Maybe your GPS is telling you that. So you know you went 100 miles. So that is just something you'll have to add in to get your total distance driven. So that'll be the right side. But first, let's just deal with the 40. So if you drive 0 hours, well, you've gone 0 miles. Again, ignoring the 100 that we already went. That'll come in later. Anyone catch the error I just made? If we've gone 0 hours, have we actually gone 40 miles? No, we've gone 0 miles. I know that was mean, but I want to pretend like I'm actually in class sometimes. So 0 hours is 0 miles because it's 40 miles per hour. Well, 0 hours means we haven't covered 40 miles yet. If we go 1 hour, that means that we've gone 40 miles because it's 40 miles per hour. If we drive for 2 hours, well, 2 times 40 is 80. If we drive 3 hours, 3 times 40 is 120. If we drive 4 hours, 4 times 40 is 160. And you can see every time we go up 1 hour, we're going up 40 miles. So you could just add 40 each time. 40 plus 160 is 200. Also, 5 times 40 is 200. So again, this is not accounting for the fact that we went an extra 100 miles before we hit the reset button on our trip. So in red, let's do the actual distance covered from home to wherever we are. So 0 hours from hitting the reset button means we've actually gone 100 miles. Because again, this time is from hitting the reset button on our trip. We hit it after having driven 100 miles. So 1 hour into hitting the trip, we've covered 40 miles plus the 100 from before, which makes this 140 miles covered. 2 hours into resetting the trip, we covered the 80 miles that's on the trip plus the 100 that's not on it, so that's 180. The next would be 220, then 260, then 300. So again, the red includes the 100, which was the fixed amount. So the red is the total driven, not just what's on our trip. Is it tripometer? I'm just so used to calling it a trip. That sounds right. It's a tachometer, tripometer. Okay, let's make our lines. Blue first. Should look pretty familiar in terms of pattern. 0, 0, then 140, 280, 3, 120, 4, 160, 5, 200. So again, that's going right 4 and up 160, right 5 and up 200, and then the same thing for the others. Connect them with a line. Do not just have these being dots. And then it looks like that pattern is going to go on at least for a little while, so we extend it and put an arrow. Now again, that was without the 100 miles on the reset button, so that's not really how far we've driven. The red is going to be how far we've actually driven. So 0, 100 is right there, halfway between 80 and 120. Go right 1 and up to 140. And all these are going to be the halfway points. They do this intentionally. In the real world, it's not always like that, trust me. In your examples, in your homework, it's not always like that. 2, 180, 3, 220, 4, 260, 5, 300. Connect with a line. Line, 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 keep it straight. Best you can. Looks like there's a good pattern there, so we extend it. I didn't extend these to the left because we can't talk about negative time. You can't drive for -1 hours. You can't drive for -7 hours. So it does not make sense to extend this model to the left. Only to the right. Excuse me. Okay. So again, moving forward in this course, the blue line, I would never even want, I would only want the red one, the one that accounts for the fixed and the variable amounts. We're just setting this up slow and steady. All right, next up, I gotta clear my screen. Objective 2 of this worksheet. Now, if you noticed, I had mentioned that I was going to put up some more discussion boards. I put up one for the midterm review. Remember, I see this, so don't you dare ask about the midterm itself once it's available. So I added a board for that, and I also added a discussion board for page 195 and 196 of your worksheet. So they give us some examples here, talk about how to make those models accounting for the variable amount and then the fixed amount as well, which ends up giving you your AX plus B type of setup here. Then they give you the cell phone problem completely laid out. They give you the answers for A and B in number 1. We're going to cover number 2 together. Y'all as a group are responsible for going to the discussion board in Canvas and completing 3A and B as well as 4A and B. So once again, y'all have to complete 3A and B. Now, there's only 4 answers. So that's only going to get points for 4 more people. Remember, I need participation from everybody ultimately. I think about 75% of you participated in the first discussion board. So I'd really like to see someone who hasn't participated yet. I don't mind if I see 1 or 2 of these done twice, but I don't want to see the same question answered 3 times. Because, well, you've already got it in front of you. And it may be right, it may be wrong. I'm not necessarily saying initially. So discuss that. If you see something that you think someone did wrong, mention it. And if I see discussions that are very wrong, I'll come in and correct, which I haven't really had to yet. I believe I did that in the first board, but it was just one mistake that somebody made. Okay, so our goal here is to write out equations, something like a y equals 5x plus 3, but using letters that are more appropriate. So like number 1, again, they have completed for us. They said that cost is proportional to the minutes you speak at a rate of 5 cents per minute. That is literally the same problem as the graph we did, or the graph they did, 5 cents per minute. It gave us the red line. But now we want to create the model as an equation. This is as a graph. Now we want the equation. So your cost, since it's proportional, is just a number times a variable, and it's proportional to the number of minutes you talk. So they say that cost is 0.05, that's the variable rate. 5 cents is 0.05 in dollars, times the number of minutes. Now they did this in words. You could also write this in letters. You could write C equals 0.05 times M. I mean, you can have it as Y equals 0.05 times X, but this one is kind of weak because the letters don't exactly tell you what's what. You really have to know which one's your input and which one's your output. Whereas if I use letters like C and M, I know M is minutes and C is cost. So then for B, they say, now assume there's your fixed cost of $20. And remember, all of these things, a total, is equal to the AX plus B in general. Again, X is just any letter. It could be M, it could be Z, whatever. Where the AX is the variable amount, the B is the fixed amount. So now assume there's an additional fixed cost of $20 each month with a fixed cost of $20. That's just being added every time. There's no multiplier for that. Multiplying would make it variable. So that's where they get this second version of the cost. You don't really need this 2 here. Just say the cost is the 0.05 times the minutes. That's the same thing as before. That's accounting for the number of minutes you talk. That's your variable cost. The 20 is your fixed cost. That's the fixed cost that just gets added. If you prefer just single letters, you could go C equals 0.05 M plus 20. Or if you just only want to use Y's and X's, Y equals 0.05 X plus 20. All 3 of these are acceptable. Now, in my math lab, you're generally not going to be writing out words. They're probably going to want this middle one in my math lab, just so you know. So let's try out number 2 together. And then remember, you're going to be responsible for doing 3 and 4. It's literally just the same as 1 and 2, except problems 3 and 4 deal with the graphs of problems 3 and 4 earlier. So problem 2 deals with the graph of 2 earlier. The weight of the water is proportional to the volume at a rate of 8 pounds per gallon. So the 8 pounds per gallon, that's our variable rate. That's the thing that gets a multiplier. So just writing this part of the proportional relationship, not accounting for the bucket yet, that says that the weight, because that's the thing that's proportional, that's the thing that we're always finding, so that has to be by itself, is the variable rate of 8 pounds times the per gallon. So some people might say gallons here, but since I used weight, I'm going to use volume. So weight equals 8 times volume. Or you could do W equals 8 V. I'm not going to do this with Y's and X's. Let me show you an alternative version using pounds and gallons. So weight is in pounds, so you might use P for pounds, equals 8G. So pounds is, the number of pounds is equal to 8 times the number of gallons. That's an alternative answer that would be acceptable. I think the W and the V are better because they don't specify units. But that's not to say that you can't get right numbers using P equals 8G. The letters don't even have to make sense. You could use A equals 8 times Q. It doesn't matter as long as you label what the letters are. Now assume the bucket you're using to carry the water weighs 10 pounds. So this is our fixed amount. So now our weight will be 8 times the volume. That's our variable amount still. That's not being affected. But now we have to add in the fixed weight of 10 pounds. Or if you use it with abbreviations, W equals 8V plus 10. Or if you use P's and G's, which is my least favorite way of doing it, but it would be P equals 8G plus 10. My favorite is this one. But again, since they use words, I wrote the answers in words as well. When you're discussing this in Canvas, you can use your words or you can use letters. I think for Canvas, it's probably better to use the words just so that everybody understands. But I'm not going to say that you're wrong if you use the letters. Maybe you answer it both ways like I did to be very thorough. So again, you must do 3 and 4 in Canvas. The problem itself is not in Canvas. You'll have to have this worksheet loaded, which you should all be able to access or have printed already. All right. How are we on time? 30 minutes. So I need to clear my screen so I can scroll. Remember I said every single Excel that we do in here always has a preview. Here's the preview. I feel like this gives you a lot of information. Here's the picture of what your lines should look like. Remember, every single Excel assignment has got some type of preview in here. This one is very, very thorough. So when you get your graph, if your lines don't look like this, if you don't follow the instructions, guess what? You're going to be losing points on that homework assignment. Follow the instructions. All right, the next thing we're going to get into is 5.2. Let us pull up our short abbreviated notes first, not those. These. Slopes and Y-intercepts. We've already mentioned the concept of slope once or twice in class. Hold on for a second. Sorry, I'm trying not to cough in y'all's ears. So we talked about slope, how when we went right and up, when we like right 1 and then up 5, or right 1 and up 7 for those cell phone plans previously, back on page, what page was that? It's pretty early in. Page 191 of your worksheets. I said that that was the slope, the 1 and the 5, the relationship between them. Slope is a measure of the steepness of a line. So the steeper the line, the larger the slope. The smaller the slope, the flatter or less steep the line is. A Y-intercept can generally be interpreted as a starting value, but when we actually get into applications, when we're using real-world data and fitting a model to it, a lot of times the starting value will not make sense. We will get into examples where some of them make sense and some of them don't make sense. So when you're using data to actually get an equation of a line, these Y-intercepts will not always make sense, and it has to do in general with how long we're looking at the model. And I don't mean like 5 minutes, 10 minutes of us actually looking at it. I mean, is this model talking about 2 or 3 years, or is it talking about 200 or 300 years? So we'll get into that later. Slope is a rate of change. Rate. What's that word? Rate. Ratio. What's that? Fraction. Slope is a fraction. Change. Change. We dealt with change in the last chapter. Change was a difference. Percent change was a ratio, but just regular old change, absolute or total change, was a difference. Well, look at this formula. So it's a rate, which means it's a fraction, and it's a rate of change, change being subtractions. So the top is y2 minus y1, the difference of the y values. It's the change, the second minus the first, the new minus the old. And then the bottom is the change of the x values, the new minus the old. Is there anything new in this concept? No. So if you just remember what the word rate means and what the word change means, rate means fraction, change means subtraction, your slope formula is automatically memorized. It's the new minus the old. You just have to remember which one goes on top. Slope is rise over run. Rise is up and down, so that's why the top has to be the y values. Run is left and right, so that's why the bottom has to be the x values. That's the only thing that you might mess up if you use interpretations versus just memorization of y2 minus y1 over x2 minus x1, which I know 90% of you are just going to memorize the formula, but the other 10% of you that are trying to be more quantitative, understanding what the words and relationships mean, that's going to be really awesome for you. Annotate. So let's say we had 0.1 here. I wish I had done that in black, and 0.2 here. In fact, I'm going to fix that. Here's 0.1. Here's 0.2. And I'll even label them as 0.1 and 0.2. P1, P2. I want to put this one on top. I have my reasons. And then we connect the line and extend it. Straight line, straight line. There's our line. The horizontal distance between the points, this is what we call the run. The vertical distance between the points, this is what we call the rise. Now the run is the change, it's the difference of the x's. So that's x2 minus x1. P2 is x2 comma y2, P1 is x1 comma y1. The rise, wrong blue, is the change of the heights, which is y2 minus y1. And then your slope is just the rise over the run. Oops. That's the illustration of where slope comes from. This dotted distance, each of those is the change. It's the difference of their coordinates. And again, this first point is x1 comma y1. The second point would be x2 comma y2. Now, we're always considering ourselves going right. Look at this. How far right you move. You don't see the word left up there at all. You will never, ever, 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 ever consider yourself moving left. We're always moving right, because moving right is similar to us moving forward in time. We don't go backwards, we go forward. We literally can't go backwards in time. If you know how, please share that with me and we can maybe be trillionaires. But you will notice that you can go up or down. Your slope is going to be positive if you're going up, and it's going to be negative if you're going down. So I'm going to draw two more quick images. This would be the positive slope, because as you go right, you're going up. This line would be a negative slope. Negative. Because as you go right, you're going down. Some people say that this doesn't rise, it falls. But you might be introducing too many words at that point. So there is a formula you have to memorize or understand the concept of slope as a rate of change. But I would never give that formula to you on a test. And you should not have that formula written in front of you when you're taking a final exam. Okay. So I need to clear my screen so that I can scroll down. To here. So we have our slope formula. Before we get into the worksheet, let's talk about the y-intercept. So y-intercepts can be found by setting x equals 0. This is the input. Whatever your input variable is, it's not always x. When we were talking about the cost of tickets, it was the number of tickets that was our input variable. When we were talking about our cell phone plan, it was the number of minutes, M, that was our input variable. So you have to know what input and output means. Input is generally what we're putting, well, in to the equation. The output is what we get out of it. Outputs are heights on graph. Inputs are how far left or right on a graph. You've got to practice this stuff. You've got to understand it. If you look at this for 15 seconds and then go try to take a test on it, you're not going to do well. So y-intercepts are equivalent to setting the x value equal to 0. So, a very, very, very important. Why is someone pulling up to my house? Oh, please don't ring my doorbell. Get my dogs going. Hold on. All right, I might have to mute you for a second. Let's see what happens. Okay. Slope-intercept form. I had said this is a very, very, very important form of a line. This is what we want all of our lines to look like as equations. Specifically, it's solved for y. That is our favorite version of lines. Good, they didn't ring the doorbell. Okay. So our favorite version of lines, mx plus b, guess what this is? This is our standard linear model. Mx is the variable amount, and b is the fixed amount. This is the same thing as what I was writing earlier with y equals ax plus b. In fact, the b's are the same letter. But now instead of writing an a in front of the x, I write an m. And the reason is because in this format, the number that's in front of the x is always the slope. As long as this is solved for y, the number in front of the x is always the slope. That is amazing because if I give you an equation in y equals format and ask you what the slope is, you don't really have to do any work. You just say, hey, the number in front of the x is 3, so the slope is 3. Boom, done. Now, what you'll see in homework problems, this is a very common type of problem. Sometimes we'll give you the slope and a coordinate. You'll plug those 3 numbers in and you'll find the b. That will give you what the y-intercept is, and then you can write the equation as y equals. I actually want to do a super quick example of this. Let's say we go through the point, let me write the slope first. Let's say we have a slope of 2, and we go through the point 1, 7. And I want you to find the equation. So the 1, the 7, and the 2 are all going to get plugged into the m, the x, and the y. We don't know what b is. This 1 and the 7, that's an x and a y value. The m, I've told you, is m. So those are the 3 numbers that get plugged into. So instead of writing y equals, we write the number for it, which is 7. Instead of writing mx, we write the number that m is, which is 2, times x. And then plus b, I'm sorry, do I write x? No, I'm rushing, sorry about that. We said we plugged in 7 for the y value. The x value is 1, so that's 2 times 1. Then plus b. And in black, I'll show what we haven't plugged in. So we don't know b, we don't know the y-intercept, but we do know a point it went through, 1, 7. So we plugged that in for the x and the y. There's the 1 and the 7 plugged in for the x and the y. And then the m is 2, so we plugged that in. And then we just got to do some algebra. So that says 7 equals 2 plus b. We're going to subtract 2 on both sides to find out that b is equal to 5. So therefore our equation is y equals, now you don't write the point anymore, just the m and the b. So the 2, we leave the x alone, and then plus the b, which is 5. This is the equation. This is the model. So we can see that the variable amount is 2 per, whatever it relates to, it's 2 per unit. And then the fixed amount is 5. So maybe we're saying that we're talking about tickets and they cost $2 per ticket, but then there's a $5 flat fee to get in. That would be the equation that models it. So this y equals mx plus b format is extremely important because it tells us so much information. In fact, because this is a 5, that's the y value of the y-intercept, I know we have a y-intercept of 0, 5. If you plug 0 in for the x, 2 times 0 is 0, plus 5 is 5. So now we have a second point. That might be helpful. Okay. So that should be everything for this section before we go on to our worksheet. I have to clear my screen. Give it about 10 more seconds. Okay. Take off annotate, new share, whiteboard. No, not whiteboard. What am I doing? Wrong class. I'm not in pre-calc. Notes. All right, let me get my red out. What just happened? Something's being weird. There we go. Okay, I don't know what was going on, but it wouldn't let me do this, what I was trying to do. Do you see this thing I just circled? Get it tattooed on your forehead if you have to. In reverse, since you'd be looking in a mirror to read it. You're going to see this over and over and over and over and over and over. Pause and over. This is a sentence. This is an interpretive sentence. We are interpreting what the slope actually means. So as a rate, slope is a rate. So it changes this much per that much thing. So we're going to talk about the output changing in relation to the input. So every time it's got these little sideways V's, that means you would be inserting a word related to the problem. So output, let's go back to the problem for the cell phone where we were changing by 5 cents per minute. Every minute that we talked added 5 cents to our total cost. That was the variable part. So when our slope was 0.05 and the input was number of minutes and the output was cost, so the interpretive sentence is the output, so that's cost, is changing by, now instead of changing, you can also use the words increasing or decreasing, increasing if positive, decreasing if negative. If the M is positive, that is. We could say decreasing if your M is negative. So the part where it says it's changing by, other phrases, you can say increasing or decreasing, but you have to say the appropriate one. If your slope's positive, if you say decreasing, that's wrong. So then next, so it's changing by. Next, we insert the slope as a number. The slope was 0.05 because it was 5 cents per minute. That was the variable rate. The units, well, 5 cents, 0.05 is supposed to be dollars. So remember, units are important, per X units. Now, notice there's no number here. It's just per X units because the slope, if you write that as a decimal, then the bottom is 1. So we're always assuming it's per 1 minute or per 1 ticket or per 1 gallon. The per is always a 1. That's consistent with everything we've done this semester. So you'll have a number for the output, but you will not write a number for the input because we are implying it's a per 1 of whatever that thing is. Again, you need to be able to make this statement. You will be making this statement. We will be making this statement, I don't know, 30 times together roughly. And this is something that when I teach this class, when I can go around the room and watch y'all, nobody wants to remember it. So this is me heavily emphasizing this. In fact, this will probably be a quiz question at some point. I'll probably do one of these quiz questions in the middle of a video somewhere. But I won't give you the full thing. You'll have to write some numbers. So that's a possibility. I'm not saying definite, I'm saying possibility. Okay. So what do we have? 10 minutes, we can get some of these done. Guided practice 1, slopes. This worksheet asks you to interpret the slopes as a sentence using the template from above. Thankfully, they have it on the screen, so I don't need to rewrite that. So here is our monthly cell phone plan. Again, this is the 3rd time we've seen it. We saw it just with the data table. Then we graphed a line. Then we ultimately modeled it as an equation. So the first thing we did today was graph the line, or that might have been the one given to us. Then we built the equation, which was also, spoilers, given to us, but we still could have done it. So this is putting everything from earlier together. Now what we want to do is interpret what this actually means, interpret the slope of the equation in real world terms. So let me get my annotate out, text, it's wide. Buddy, you were snoring so loud today. Sorry. Like I said, I don't think y'all can hear that. So how do I know what to type? Do I need to find something from the internet? No, this is a template. Write the words from left to right. Don't look at, oh, X units, let me think about that, then think about slope, then think about output. No, the output. What's the output of this? We were talking about cost. This thing was always spitting out a cost. The height of this graph was a cost. The Y was interpreted as cost. In fact, when we use letters C and M, the C meant cost. So cost is the output, is changing by. Now, if I wanted to be more specific, I know that this is a positive, so I could say is increasing by. Then you write slope. You don't write the word slope, you write the number for the slope. Well, in this format, the slope is always the number in front of X. So that's 0.05. So it's changing by 0.05. Then after that, you write the units that the cost is in. Well, cost is in dollars. So it's changing by or increasing by $0.05. You could also say 5 cents if you wanted to. Okay, what comes after that? The word per. How did I know that? Because I'm looking at the template. And then the next thing that comes after it is the units of the X. We don't need to write a number because we always assume that it's per one of those things. What are the units of the X? Well, the X is in minutes. So that's per minute. That is our real world interpretation. The cost is changing or increasing by, because it's positive, 5 cents a minute or $0.05 per minute. I'm sorry, I'm laughing at my dog. He's a goof. That's it. All you have to do, oops, come off of annotate. There we go. Is take the template, the output. What's the output? Cost. Is changing by, is changing by. The slope as a number was the 0.05. The units of your output, which was cost, are dollars. Then the word per, and then the units for the X were in minutes. Do not do this one time, do this 50 times, do this 25 times, do this 100 times, however many times it takes you to get used to this sentence, because guess what? You're not going to be given the template on a test or in a homework question necessarily. I mean, it's homework, so yeah, you can look at it, but the point is to be able to, after this is all over, be able to do this on your own. And you can't learn this by doing it once or twice. We learn by repetition. Time, 10:40. I think we can knock out one more of these. I need to clear my screen. Otherwise, that's going with us. So we'll do number 2. Annotate. So concentration of pollutants. So maybe we've got a lake that somebody dropped a pollutant into. Maybe someone accidentally dumped some oil or gasoline into it. Or maybe we're just talking about the air and a concentration of a pollutant. So maybe the coronavirus is just everywhere. And ppm means parts per million. That is a very common unit for concentrations of pollutants, not necessarily even pollutants, just anything, for concentrations of things in water or air. ppm, parts per million. So they give us the model. They give us a graph. We never developed any of this. This negative 0.8, that is our slope. The 100, that is our Y-intercept. So that's interpreted as a starting value. Now, I didn't ask about this, but that says that we're starting out with 100 units of this concentration, 100 parts per million. But then over time, the pollutant starts to diffuse and it gets weaker and weaker and weaker. So that's why this is going down. That's why this is a negative slope, because the concentration is dropping over time, and the horizontal axis is in days, so that's time. So interpret the slope using that thing from earlier. And unfortunately, I don't think copy paste works with text here. Let me see. Nope. Oh, yes, it does if I use Control V. I just can't right click it. Good thing I know my computers. So again, this is the template that we're using. So interpret the slope. I didn't ask about the intercept. I mentioned it, but that's not what I'm going to type about here. So again, just using the template from left to right, pay attention. Where am I getting this? It's all right here. Then the output. What is the thing that's being output? Well, it's the thing in parts per million, but that's a units. It's actually called the concentration of the pollutant. And then we say the next words after that, it is changing by. You could certainly mention increasing or decreasing if you wanted to be more specific, but this is just the less specific version, the more vague version. Then we write the slope. The slope is the number in front of the variable, which is negative 0.8. So it's changing by negative 0.8. And then we write the units on the Y scale. The Y scale units are parts per million. So we're dropping 0.8 parts per million. Then after that, the word per comes, per, and then the units on the x-axis. The x-axis is on time. Specifically, the units are in days. So every single day, the concentration of this pollutant is changing by or decreasing by negative 0.8 parts per million. Now, if you say decreasing, you don't want to have the negative there. Again, if you use the phrase decreasing by, do not put the negative, do not put the negative. I know that most of us are just going to say it's changing by, so we definitely have to have the negative there to show that it's decreasing. So again, the thing that we're discussing here, that's the concentration of the pollutant. The thing is changing by, then the number, then the units on the Y, then the units on the X. If you swap the order of the units, it's wrong. If you write 100 here instead of negative 0.8, it's wrong. If you miss the negative, it's wrong unless you use the phrase decreased by or decreasing by. Ing, not ed. So we'll do 3 and 4 next time. For now, we're going to go ahead and call it a day. Please remember that all this stuff, your review is up. It's closer to 60 questions. I think it was 58 or 59. Don't quote me on that. The midterm will be available in a few days. I want to make sure people only see the midterm review for a little bit. Please do this midterm review. I had one of my other classes, and I actually made theirs a My Math Lab assignment because their grading works differently. Not even half the class did the review. And you know what? I'm pretty sure that there is a correlation, we'll talk about that later, between the people that did the review and did well on the test. Do the review, because I'm pulling questions from the review for the actual midterm. I'm not joking about that. Almost every single question will be from the review. I mean, yeah, you got to study a few extra problems, but at least you know what not to study. That's what the midterm review is doing for you. As I said, there's only going to be one question that's going to be a little different from the midterm review, but it's still basically in the midterm review. I'm just changing the perspective a little. All right, so at that note, please have a good day. Please keep up the work. Please work hard, and we will see you on Wednesday.